Okay, here is our Chapter 13 review. Question 1. Solve for B in the right triangle shown at the right where A equals 50 and C equals 20. So, right triangle means that we can use SOHCAHTOA. You could also solve this with the law of sines, but I am going to show the SOHCAHTOA method. So they said A is 50, C is 20, and then I'm going to label the opposite, adjacent, and hypotenuse. So C is the hypotenuse, A is the opposite, and B is the adjacent. We want B, so we want the adjacent. We know the hypotenuse, so we are looking for where we see A and H together in SOHCAHTOA. So we see the A and the H right there with the C, so we are going to use cosine. So cosine of the angle, so it's the angle that comes right after the cosine, so in this case that's a 50, equals adjacent over hypotenuse. So I'm going to put this over 1 and cross multiply. So B times 1 is just B, and then cosine 50 times 20. And actually I always write the number first, so 20 times cosine 50. And we should get 12.9. Okay. Question 2, solve the equation cosine of theta equals 7/16, where the angle is between 0 and 90. So this one you just put in your calculator. So we want to get rid of this cosine, so we are going to use the inverse cosine. So inverse cosine, inverse cosine. So theta equals inverse cosine of 7/16. And I got 64. So theta equals 64.1. Is that between 0 and 90? Yes, then we're good to go. So now the next question, we have the exact same starting value. So I know theta is going to equal 64.1 when I put that in my calculator. But now I need to find that same value, but where theta is between 270 and 360. So here's my graph. 270 is at the bottom, 360 is at the side. And I'm going to draw my line here. And then I'm going to put in the 64.1. So remember that reference angle, this becomes a reference angle, goes between the line and the x-axis. So 64.1. So then my answer is all this. So 360 minus 64.1 will give me my final answer. And I got 295.9. So now this number, is this between 270 and 360? Yes. So this is our answer. Question 3. All right. A satellite orbiting the Earth passes directly overhead at observation stations in Phoenix and Los Angeles, 340 miles apart. At an instant when the satellite is between these two stations, its angle of elevation is simultaneously observed to be 60 at Phoenix and 75 at Los Angeles. How far is the satellite from Los Angeles? So I'm just going to redraw this picture a little bit better because it's kind of small. So this is LA. This is Phoenix. And this is the satellite. 2 L's. I'm going to zoom in here. We've got 340 on the bottom, 75 by LA, $60 by Phoenix, and it asks how far is the satellite from Los Angeles. So our X is on this side. So looking at this, we can figure out one of the other angles very easily. So this angle up here, I'm going to do 180 minus 75 minus 60, minus. And I get 45. Now I've got this pair together and I can do law of sines. So sine of 45 over 340 equals sine of 60 over that x we want, the distance from LA to the satellite. Cross multiply. So x times sine 45 equals 340 times sine 60, and divide out this sine. All right, so x equals 340 times sine 60 divided by sine 45. And I got 416.4. All right. And then just kind of looking at my work, 60, the angle across from the distance we were looking for, is bigger than 45. So it makes sense that my answer is bigger than 340. Then the side we didn't find would be the biggest of all. And yeah, that one's done. So next page. A tunnel is to be built through a mountain. To estimate the length of the tunnel, a surveyor makes the measurements shown in the diagram at the right. Use the surveyor's data to approximate the length of the tunnel. So they give us side, angle, side. So, and we want this side across from it. So when we've got side, angle, side, or basically when we don't have an angle and a side from the same set, we don't have capital A and little a, we don't have capital B and little b, then we're going to have to use law of cosines. So law of cosines, when we're finding a side, is that really big, long problem. So x squared, and then the other two sides, it doesn't really matter what comes first. So 212 squared plus 388 squared minus 2 times 212 times 388 times cosine of 82.4. So we've talked about this before. I just want to say again, these are all times back here. They look a little bit like minus. That even though this is long, it just all goes in your calculator. So 212 squared, 388 squared, 2 times 212 times 388 times cosine 82.4. And I got x squared equals 173,730.2. Square root both sides, and x equals 416.8. All right. Yes, we use approximate the length of the tunnel. There it is. So question 5, using the triangle at the right, first find x, then find the area of the triangle. So to find x, I'm going to use law of sines. So we can figure out this missing angle pretty easily. 180 minus 52 minus 70, and we've got 58 up top here. Then we can put together the angles with the sides. So sine 58 over 23.1, sine 52 over x. Cross multiply and divide. So we get x equals 23.1 times sine 52 divided by sine 58. I got 21.5. And then the area formula. So we've got a couple different area formulas to choose from, but one needs all three sides, and we don't have all three sides. So I'm going to use that the area equals 1/2 times A times B times sine C. So the two sides I have are the 23.1 and the 21.5. And then the angle has to be the angle in between them. So that is the 70. So 0.5 times 23.1 times 21.5 times sine 70. And I got the area equals 233.3. All right, let me know if there are any questions, and good luck.